In June 1994, the Ulysses spacecraft will begin an expedition over the poles of the sun. Its mission is to study the sun and the solar atmosphere expanding into space. Little is known about this star at the center of our solar system, yet it dominates all of life on Earth. To reach the high solar latitudes never before explored, the spacecraft must use the gravity of an immense planet, Jupiter, to bend its flight path out of the plane in which the planets orbit. Looping back inward toward the sun, the spacecraft will then journey on to the sun's southern pole. Ulysses was launched on October 6, 1990, aboard the space shuttle Discovery.
Ulysses is jointly managed by the European Space Agency and the National Aeronautics and Space Administration. The Europeans built the satellite, NASA provided a launch vehicle, a power source, and is currently tracking the satellite on its way to Jupiter, where it'll pick up a gravity assist, which will take us over the sun's south pole, by the equator, and then on to the North Pole.
9 science experiments will study the solar wind and energetic particles streaming outward from the sun's corona. The experiments will also study cosmic rays entering the solar system from interstellar space.
Ulysses will measure many aspects of space within the solar system, including interplanetary dust. The variations with solar latitude will provide important information about how the solar wind is able to escape from the sun and the effect that it has on cosmic rays entering the solar system from the galaxy.
16 months and 575 million miles after launch, the spacecraft will begin these investigations when it arrives at Jupiter. Closest approach occurs on February 8, 1992. The experiments will be used to study the region dominated by the rotating magnetic field of Jupiter, called the magnetosphere. Particles trapped within Jupiter's magnetosphere come from 3 sources: the solar wind, Jupiter's upper atmosphere, and Jupiter's moons. One of Jupiter's moons, Io, contributes gas to the Jovian magnetosphere at a rate of nearly 1 ton per second. This gas becomes ionized and forms a ring called a plasma torus that circles the planet. Ulysses will measure the composition of this donut-shaped plasma ring. At greater distances, a rotating sheet of plasma encircles Jupiter. Centrifugal force slowly drives gas in the plasma sheet outward until it eventually escapes from Jupiter. Outside Jupiter's magnetosphere is the solar wind. This wind blows at speeds of about 1 million miles per hour. The wind cannot penetrate the Jovian magnetosphere, but is deflected around it. Ulysses' predecessors, the Pioneer and Voyager spacecraft, entered the Jovian magnetosphere where the local time was near noon and exited in the pre-dawn region of the planet. The Ulysses spacecraft will follow a path similar to its predecessors as it enters, but will leave the magnetosphere on the dusk side of the planet. During its 10-day tour of the Jovian system, Ulysses will perform new experiments and explore regions of the magnetosphere not visited by the other spacecraft. From there, Ulysses will be on its way to explore the poles of the sun.